a video on doing a test of two proportions. Okay, so we're going to look at the Mythbusters seed yawn one. Okay, our null is that there's no difference between the percentage of people who yawned who were seeded and who weren't seeded. Right? In other words, PS is equal to PN. And on the side, I explained what those variables are. It's the percentage of people who yawned that got the seed and the percentage of people who yawned who didn't get the seed. So our null and our alternative is that you're more likely to yawn if you get the seed. So PS is greater than PN, or the difference is greater than 0. I checked my conditions: random, normal, independent, random. Okay, they were randomly assigned. People were randomly assigned to either a seed group or the non-seed group. Independent, one person should not affect another one. They were all separate from each other, so that should be fine. Normal, there were 10 or more yawners and non-yawners in each group. That's the NP greater than or equal to 10 and 1 minus P greater than or equal to 10 for each group. It's a little easier to write like that. Okay, and the idea here is that if we did this many, many times and the null was true, we would get a difference, and it would be centered at 0. The average difference would be 0 between the two groups. Sometimes we'd have more on this side, more people who yawn with the seed group, and sometimes this side, if the null was true. We got 0.038%, so 3.8% more yawners in the seed group. And we're looking at that red area. How likely is it to get that result if the null is true? Okay, that's our whole problem. And this is we're talking about proportion, so it's norm CDF, 0.038, 99, 0, 0.091. Well, let's talk about that. 0.091 is the kicker there. Okay, so and for the record, in case you forgot, the percentage of people who yawned in the seed group was 28.8, and in the non-seed group was 25%. So we got a difference of 3.8. That's where that 3.8% came from. That's what we got. All right. So what we do, hold on one second. What we're going to do is we go in with the null being true. If the null is true, well, there's no reason to separate the groups. We pool or combine the percentages. So 27 out of 99 people yawned. And if there's no reason, if our null is true, there's no difference between the groups. 27.3% of people yawn. Okay. Now on the AP formula sheet, we have two formulas. We have this formula for standard deviation, and we're going to use that for confidence intervals. But in a special case, when our percents are the same, okay, when our percents are the same, we use this formula here. We square root P, and it's the same formula, they just take stuff out. Okay, so and off to the side, I use those numbers, that 0.273 and 1 minus 0.273. So you can see it there, square root of that. And if you did that all out, it gives you 0.338. So that's our standard deviation. The kicker there is again, we pool. We bring the percentages together for those first numbers. All right. And then when we do our norm CDF with that 0.091, the standard deviation that we got, we get a final answer of 0.338. So in conclusion, because 0.338, our p-value is above alpha of 0.05, we fail to reject our null. In other words, we have no evidence to say that people who received the seed were more likely to yawn.